Okay, we're going to do notes today over 8.4, which deals with Pascal's triangle, and it's used to expand a binomial of the form x plus y raised to the n power. And what I mean by that is if we have something like x plus y to the third power, we have to do x plus y times x plus y times x plus y in order to get that expanded. That's not so terrible, but if I ask you to do something like x plus y to the seventh power, that's multiplying that binomial times itself 7 times, which is a pain. So Pascal's triangle helps us with that. So what it does is you start with, what it gives us is the coefficients for the expansion. So if you start with 1 on Pascal's triangle, that's because x plus y raised to the 0 power is just 1. When I do x plus y to the first power, I get x plus y. The coefficients of those terms are 1 and 1, so we put 1 and 1 here. When I do x plus y squared, and I multiply that out, I'm going to get the coefficients of 1, 2, and 1 for the 3 terms that we get when we multiply that out. And the way where I got that 2, if I just use Pascal's triangle, is those two numbers add together to be 2. You always have 1s on the end. These two add up to be 3, those two add up to be 3. So these will be the coefficients when I do x plus y to the third power. So I'm just going to keep doing that. I'm going to have 1 on either end. 1 plus 3 is 4, 3 plus 3 is 6, 3 plus 1 is 4. So those will be the coefficients for that one. And then I'm just going to fill this in real quick. You might fill it in with me and then check your answers. I'm going to pause this. Okay, this is Pascal's triangle filled in. One thing I want you to notice is, for example, when we're doing it raised to the power of 2, then this second number is 2. When I do n, where n is 4, so that means I'm raising x plus y to the fourth power, the second number will be 4. So that's the row that you're going to in order to get the coefficients that you'll need for that expansion. All right, let's do an example so it kind of makes more sense. Okay, we're going to expand x plus y to the fifth power. So remember, that's like saying x plus y multiplied times itself 5 times, which would be a pretty big pain. So what we're going to do, I've kind of written Pascal's triangle over here to the right. I'm going to use this row of Pascal's triangle because that second number is 5, and we're raising this to the fifth power. All right, so let's do this. I'm going to have these numbers in Pascal's triangle represent the coefficients. So we start with 1. I'm going to take that first term x, and it gets raised to the highest power that we have, which is 5. The second term y will be raised to the lowest power, which is 0. So all of your first terms, the x's, will go down now in power, and the y's will go up. So the next term, I started with the 1 right here. Now I'm going to do 5. So 5, and then x is now raised to the fourth power. Y is raised to the first power. So x's are going down and y's are going up. The next number that will be the coefficient is 10. So 10 times x cubed and y squared. The next one is 10 again. So 10, and now x will be squared. Y will be to the first power. I'm going to erase some of this. Okay, the next one is 5. And x is to the first power, y is now to the, oh gosh, I did that wrong, I'm sorry. This y right here should have been cubed because the y's are going up, and this y right here should have been to the fourth. Sorry about that. And then plus, the last one has a coefficient of 1, x is now to the 0 power, and y is to the fifth power. So again, if you'll look at all of your exponents, the x exponents go from 5, 4, 3, 2, 1, and 0. The y's go up in power, so 0, 1, 2, 3, 4, 5. Also, what I want you to notice is when you add those exponents, they should match this exponent that we're raising it to. They should be 5. So 4 plus 1 is 5, 3 plus 2 is 5, 2 plus 3 is 5. So another way to check yourself. All right, so if you were to write this out in simplified form, you would just say x to the fifth. You probably wouldn't say a y to the 0, you would just leave it x to the fifth. And then plus 5x to the fourth y plus 10x cubed y squared plus 10x squared y cubed plus 5xy to the fourth plus y to the fifth. And that is the expanded form of x plus y to the fifth power. All right, let's do another one. So now we're going to do Pascal's triangle, and we're doing the fourth row. So this will be 1, 1, 1, 2, 1, 1, 3, 3, 1, and 1, 4, 6, 4, 1. So we're using this one. These will be the coefficients. I'm just going to write it here so we have it. And I'm going to erase it so that I have more room. Okay, so we start with 1, the coefficient 1. I'm going to take x squared, and it's going to get raised to that highest power 4. The 2 is going to get raised to the lowest value 0. And then the next coefficient will be 4. X squared will now be 3, and 2 will be raised to the first power. Plus 6, x squared will be raised now to the second power. 2 will be raised to the second power. And then plus 4, x squared will get raised to the first power because it's going down. 2 will get raised to the third power. And then plus 1, x squared is now raised to the 0 power, and 2 is now raised to the fourth power. Okay, let's simplify that some. So remember, when you have x, you're raising a power to a power, you multiply those two. So that becomes x to the 8th. And remember, 2 to the 0 is just 1. I'm going to show that. So there's 1 there. And we had technically a 1 out front. Plus, you've got the 4, and that becomes x to the 6th times 2, plus 6, x to the 4th, and then 2 squared is 4. I'm showing lots of work here. You probably wouldn't have to show this much work. And then 4x squared, that 2 to the third power is 8. And then plus x squared to the 0 power is 1, and then 2 to the fourth power is 16. All right, so simplify that a little bit further. That becomes x to the 8th. You're going to multiply this 4 and the 2 together because they're all one term. So you're going to go ahead and simplify that by multiplying those. So that becomes 8x to the 6th. And then on the next term, you have this 6 and this 4 that you need to multiply together. So that's going to be 24 x to the 4th. And then next you have this 4 and 8 that need to be multiplied together. So that's going to be 32x squared. And then lastly, you have that 16. And that's x squared plus 2 raised to the fourth power when you expand it. Okay, let's do another one. Okay, I've written Pascal's triangle over to the right. I went down to the 6th one because the number 5 here has us going to the 6th one. Okay, so we're going to expand 2x minus y to the third power. So I'm going to focus on this one right now. All right, so that means my coefficients are going to be 1, 3, 3, and 1. So you start off with the 1. 2x is going to be raised to the highest power, so 3. Negative y, don't forget that sign, is raised to the 0 power, plus 3. 2x is raised to the second power now. Negative y is raised to the first power, plus another 3. 2x is now raised to the first power. Negative y is now squared. And then plus 1. 2x is now to the 0 power, and negative y is cubed. All right, so simplifying that. When you, well, I'll show my work again. So you've got 1. When you cube 2x, you're cubing all of that. So that becomes 8x cubed. And then negative y raised to the 0 is 1. Plus, you've got 3. When you square 2x, it becomes 4x squared. And then negative y. And then plus 3, 2x. Negative y, when you square it, just becomes positive y squared. And then plus 1, 2x to the 0 power is 1, and then you've got negative y cubed. When you cube a negative number, it stays negative. All right, I'm going to simplify that more. So this whole term becomes 8x cubed. That's supposed to be an 8, sorry. Plus this whole term, you've got 3, 4, and a negative 1. So I just made a mistake. This should be a minus sign because that negative right there. So that becomes a negative 12x squared y. And then here for this term, we've got 3 and 2, which are going to multiply to be 6. Then you've got x and y squared. And then the last term, you've got that negative, so make sure you make a negative there. And so you have a negative y cubed. So if you'll notice, when you have a minus sign in that binomial, you're changing signs every other term. So just don't forget that. All right, so that's that one whenever you expand it out. Let's do the next one. So now we're doing x minus 2y to the 5th power. So this time we're using this row. So I'm going to write those. That's 1, 5, 10, 10, 5, and 1. Those are going to be our coefficients that we'll use for each of these terms. So we'll start off with 1, and we'll do x to the 5th power. Really, I probably should have put that on the outside of the parentheses. I'm going to fix that because I want to make sure you understand that needs to happen. This 5 needs to go on the outside of the parentheses because everything in that parentheses is raised to the 5th power. It doesn't matter with x, but it's going to matter with this negative 2y when we start expanding it out. So that's negative 2y is raised to the 0 power. So plus 5, and then x is now to the 4th power. And negative 2y is raised to the 1st power. Plus 10, x is now raised to the 3rd power. Negative 2y is now squared. A way to check myself is make sure those exponents add up to be the 5 that we have right there. So plus 10, x is now squared. Oh, goodness, sorry. Negative 2y is cubed. Plus 5, x is now to the 1st. Negative 2y is to the 4th. Plus 1. I'm going to write it down here, I'm sorry. X is now to the 0, and negative 2y is to the 5th power. All right, let's simplify that. So this becomes, remember this is just, I'm going to change my pen color. This is just the number 1. So that simplifies to be x to the 5th. Plus, or I'm sorry, actually I need to focus on the fact that I have a minus right here. So that's going to be a minus, and then you're going to do that negative 2 times the 5, which gives me a negative 10, x to the 4th y, and then plus, you've got this right here simplifies to be 4y squared. So you do the 4 times the 10, and you get 40x cubed y squared. Here, the negative 2y cubed is the same thing as negative 8y cubed. So negative 8 times 10 is a negative 80, x squared y cubed. And then here you've got this negative 2y, all of that's being raised to the 4th power, so that's 16y to the 4th. And when you multiply 16 times 5, you get 80. So that'll be 80x y to the 4th. And then on your last one, this negative 2y to the 5th power is going to be a negative 32y to the 5th. This x to the 0 was a 1. I forgot to say that. All right, so that is the expanded form of that binomial. Okay. On the next one, they're asking us to find the 7th term of x minus y to the 6th. So this time we're using this bottom row of Pascal's triangle. I'm going to write that out. So we've got 1, 6, 15, 20, 15, 6, and 1. So if I'm looking for the 7th term, this is the 1st term, 2nd, 3rd, 4th, 5th, 6th, and 7th. We're using that coefficient, the 1. So I'm going to put the 1 here. Remember, this was going to be x to the 6th, x to the 5th, x to the 4th, x to the 3rd, x squared, x to the 1st, and x to the 0. So we're going to have x raised to the 0 power. And then that negative y, you know, you started off here with y to the 0, y to the 1st. It was increasing. Y to the 3rd, y to the 4th, y to the 5th, and y to the 6th. So this will be negative y to the 6th power. When you raise a negative number to an even power, it becomes positive. So this answer is just y to the 6th. And that's our answer. All right, let's do another one. Okay, on example 6, we're going to find the 4th term of the expansion x minus 10z raised to the 7th power. So the 4th term is this term here. So our coefficient we know is going to be 35. We're going to take that first term x. Remember, this would have been x to the 7th power. This would have been x to the 6th, x to the 5th, and this would have been x to the 4th. So this will be raised to the 4th power. That second term, negative 10, z, we started off with z to the 0, and then to the 1st, 2nd, 3rd. So this should be to the 3rd power. And another way to notice it is that these two have to add up to be that 7 right there. All right, so if we were to simplify this further, that would be 35 x to the 4th. And then negative 10, when you cube it, it becomes a negative 1,000 z cubed. And so that simplifies to be, I forgot my negative, sorry. That simplifies to be a negative 35,000 x to the 4th z cubed. And that's your answer for that one. All right, on the next one, I went ahead and wrote out Pascal's triangle for those rows. I hope that was okay. Now we're going to find the coefficient of the term x to the 6th y squared for this expansion. So if you'll notice, we have x to the 6th power. Remember, this was x to the 8th power. Since this was 8, it had to match that. X to the 7, x to the 6. So we're focusing on this one. So we're going to have 28 as our coefficient. And then our first term is 2x. It's going to be raised to the 6th power. Then negative 3y, remember those two exponents have to add up to be 8, so this will be squared. So simplifying that, you get 28. 2 to the 6th power is going to be 64, x to the 6th. Negative 3, when you square it, is a positive 9, and then y squared. Okay, so now when we multiply that out, we'll multiply the 28, the 64, and the 9, and we get 16,128. And then x to the 6th y squared. Now this question asked me to find the coefficient, so my coefficient is just 16,128, and that's your answer. Okay, that's our notes for today. Thanks, guys.